For the last few years, I've always wanted to make my own gaming handheld. Until now. I've never made a console before, so for some reason the first thing I had an idea was to just sketch out what it should look like. I have no idea why this would help me, so after that I went directly into the PCB making and started up working on the schematic. I still don't really know how to design PCBs that well, so I'm going to keep this one simple, and I've just placed down a Arduino, a couple buttons, and an analog joystick. After that, the routing is fairly simple, and once I do one side, I can pretty much just mirror it right over for the other side of the controller. While the board is fairly simple, I think it gets the job done good enough, and it might be time for us to order it. But first, this project was possible thanks to our sponsor, JLCPCB. They're the #1 service when it comes to fast, reliable, and affordable PCB manufacturing. I've used JLC for many projects before, and every single time I was impressed with their quality. So let's go over to jlcpcb.com, and it's about as easy as just dragging your Gerber zip file right onto the screen. Once it uploads, you can preview your board and get an instant quote. You can also adjust things like the color and the material. It's that easy. Just hit order and they'll show up at your door in a week. The boards have arrived, and as you can see, they're high quality and exactly what I expected. Be sure to check out JLC PCB using the link in the video description below. Now back to the video. After breaking apart my boards, they had some jagged edges, so I decided to sand them down a bit. Always make sure to breathe as much as possible while you're sanding to fill your lungs with the maximum amount of particles. Here's all the parts I ended up using: a screen, battery, some buttons, our PCBs, Arduinos. I started by assembling one of the controllers. They're very simple and even a beginner could do it, since they're mostly just through-hole components. You're free to judge my solder joints in the comments, but I thought I ended up doing pretty good. Half these pins flew across the room while I was cutting them, and I'll probably never find them until I step on them at 3 AM. We are done with one of the controllers. I'm just going to plug it in really quick to see if it actually works or not. Well, look at that. It works perfectly fine and did not explode at all. Now we need to make a second one. We have made a second one.
Yes.
All we need to do now is to wire them together so they are registered as one controller instead of two. We're done wiring up the controllers, and now we can just set these aside and work on the actual console part of it. The console itself is fairly simple. You pretty much just connect all the wires for everything and hope it turns on. This is the battery charging board. It's kind of big, but it'll do. We got everything connected up, and it seems like it boots the OS fine. Now we need a 3D printed case. After a bit of the worst CAD I've ever done, we have somewhat of a model. My models will have to do for now, but my CAD was so bad that a friend from my Discord actually offered to help me make a better model. You should totally join the Discord, by the way. But I already did all the prints, so we might as well use them in this video. I know what you're thinking. Wasn't he just using a Pi 5 earlier? And that's true. But I broke my Pi 5. It turns out wiring the power rails backwards kind of cooks it, and I honestly don't want to wait another 2 weeks for the shipping for a new one, so we're going to be using a Pi 3. Too bad. So I finished the assembly, and the console is finally ready to be tested. Here's the finished device. It doesn't look the best, but it's pretty good for a first prototype. But the big question is, can she game? Here we are on the desktop. For now it's just PiOS, but in the future I plan on coding a UI, sort of like the Steam Deck has. I'll probably do that on a live stream, so subscribe so you don't miss that. But for now, let's just test out how the games perform, if they even run. I haven't made any proper games yet, because this pretty much can only run games that I code for it. But here's a spinning cube made in Godot 4, and it's running at about 50 FPS stable, which I think is pretty good considering that it has shadows and lighting. I think this console definitely has a lot of potential, because here's a second game which is way more graphically intense than the other one, and it's running at over 200 FPS. So, I don't know, you tell me. If anyone's actually still watching this, then thank you for sticking around, and just consider subscribing. I'll see you guys in the next video.